Before 2017, teaching a machine to understand language was a slow, painstaking process. Models like recurrent neural networks had to read a sentence one word at a time, from left to right, just like us. This created a bottleneck. By the time the model reached the end of a long paragraph, it often struggled to remember what was said at the beginning. It was like trying to follow a complex story while having short-term memory loss. This sequential design fundamentally limited how well an AI could grasp context, nuance, and the long-range connections that make language meaningful. The field needed a way to break free from this linear plotting. Then, in June 2017, a paper with a deceptively simple title appeared: Attention is All You Need. Authored by a team from Google, it proposed a radical departure. It asked, what if a model didn't have to read sequentially? What if it could look at every word in a sentence all at once and instantly understand the relationships between them? This was the magic of their new architecture, the transformer. The core idea is self-attention. Imagine the sentence, the robot picked up the ball because it was red. A human instantly knows it refers to the ball. Self-attention gives an AI this same ability, but on a massive scale. It creates a web of connections between every single word, weighing the importance of each one relative to all the others, simultaneously. And since the model no longer relied on word order for processing, the authors gave each word a kind of digital timestamp, a positional encoding to keep the sequence straight. The impact was immediate and explosive. The transformer didn't just inch past the old models, it blew them away, setting new records in machine translation. But its true legacy was becoming the fundamental building block for the AI revolution that followed. That GPT model powering your favorite chatbot, it's built on a transformer. Google's BERT, which transformed how search engines understand your queries, also a transformer. This architecture unlocked the ability to train on unfathomably large amounts of text, leading directly to the powerful general-purpose AI systems we interact with every day. The 2017 paper wasn't just an improvement, it was a new foundation for the entire field. But this incredible power came with an immense appetite. Transformers are notoriously resource-hungry. Training a massive model like an early version of GPT-3 consumed enough electricity to power hundreds of homes for a year, leaving a significant carbon footprint. This bigger is better approach also meant the models inherited and sometimes amplified the biases present in their vast training data. Furthermore, the very complexity that made them so powerful also made them opaque, black boxes, making it hard to understand their reasoning. The community was forced to confront a difficult trade-off: performance at what cost? The breakthrough had created a new set of monumental challenges. The story of the transformer is still being written. Today, the focus has shifted from raw power to efficiency and intelligence. Researchers are developing clever solutions like sparse attention, which teach models to focus only on the most relevant connections, ignoring the noise. Techniques like model distillation train smaller, student models to mimic their giant teacher counterparts, offering similar performance with a fraction of the environmental cost. And architectures like mixture of experts create specialized networks that only activate when needed, like calling in a specialist instead of making the whole hospital work on one case. The paper's title, Attention is All You Need, proved to be prophetic, but we've since learned that where we focus that attention, both in our models and as a society, is what will truly define the future of this technology.